Hello everyone, my name is Tatiana and I teach mathematics at London School of Mathematics and Programming. Before I start my formal presentation about the topics we covered in the autumn term, I would like to say a few words about myself. As a child, I love mathematics and experienced many different types of learning. Apart from the normal school, there were math circles, there were correspondence courses, there were popular math books and magazines. I was also studying in a boarding school with math specialism in Moscow. I graduated from Moscow Institute of Physics and Technology and have been teaching math ever since. I worked with pupils of all levels. At one end, there were children who, according to their teacher's opinion, would never catch up. And at the other end, there were some child prodigies and math Olympiad winners. I worked in state school and private schools. I worked with full classes in small groups and one-to-one. I prepared my pupils for entrance examinations in university in Russia, helped them with their American SAT tests, and also with French baccalaureate. So as you can see, I have quite extensive experience, and this certainly helps me with my current job. So I'll just share my screen and show you the tasks that I offered my pupils in the last term. So let's start with the youngest one. This is just the indicative, the years that don't mean much because it could be below 7 or above 9, and it could be different groups. So there is no special topic for this task. It's just a puzzle involving some symbols that children are expected to replace with numbers, or maybe not, maybe they just should answer the question, because sometimes it's impossible to determine the symbols just merely from the numbers given. So this is just a series of questions, and there are different types of them. There were different types. In some of them, they have to find out the value of each symbol, and sometimes they just need to compare different rows or different columns. Sometimes they need to look at the totals. So as usual, I try to present not just random tasks, but questions and problems in some series, so that there is some feel of development. You see 6 identical squares. This is exactly how your children would see that on screen, because they each have their own area of screen to work on, and it works really well. They love it that they have their own space where they can scribble, draw. That's again with the youngest one. We talked about totals, sums, and how to share a given set of cards with numbers between 2 or maybe 3 people. Again, this was just one task among the series of tasks of a similar type with different difficulties. There were some questions where we worked with cards having numbers in arithmetic sequence. Sometimes there were just some random numbers. And the idea is that we don't just try to randomly find the solution. We try to find the idea. What can we use? Can we find some shortcut? Can we find something smart to deal with the question? And another puzzle for the youngest. Put the numbers into the circles according to some special condition. In this case, the sum of 3 numbers next to each other shouldn't be too big, it should be 11 or less. This is a very good task because it turns out that there are seemingly different solutions, but they are in some way identical, and we discussed this as well. Also, we can prove that there is only one solution up to reflection and rotation. And maybe this would be just the very first example where children meet the idea of necessity of proof. And another puzzle, we try to find the path from one square to another. Once again, they work at the same time, simultaneously on screen. They might find different solutions. They might come across the same one. It's good to compare. It's good to discuss. And again, this was one of the series of questions. Some of them didn't have a solution, and again, we had to find a proof why the particular task doesn't have a solution. I think it's very important. And at this stage, when children are not very familiar with mathematical theory, this idea that sometimes is impossible to do, and they need to explain why it is impossible. This is this gives them a good motivation to present the proof, and they start appreciate the importance of proof. Now we move to children who are slightly older. This was a series of tasks about shapes that differ in various ways. And we started with this table where they are presented in some systematic way, and they had to guess what exactly this way is. You might notice that the smaller shapes are in the top half of the table, the bigger ones in the bottom, the solid shapes on the left, and the ones with the hole on the right. And they enjoyed this task a lot. And we worked with these shapes and compared their features in different tasks later. This is a geometry task. Children love geometry because this is about drawing, and they can show creativity. The 16 dots for the grid. Everyone has 16 dots. And it turns out, surprisingly, all 16 dots could be vertices of a single polygon. And they're really, really amazed when they find this polygon. And again, there is only one solution up to reflection and rotation. And this is a really good task. And when we draw the polygon, we find its area in terms of the squares, which is additional, which adds some difficulty, because there are different ways of working out the area. We compare them. We find the best, the most efficient way of finding the area as well. We worked a lot with polyominoes, and these are pentominoes. I asked the children to show how these pentominoes could look differently. What happens if we rotate or reflect them? They drew different looking shapes that were in fact equal. They are congruent, identical. We discussed why it is that some shapes have more different views than others. It's about symmetry and transformations. It's a good step towards more advanced math in the future. And after we finished recognizing equal shapes, we work with tessellations. This is a tetromino, L tetromino, and the tiling presented. Children saw this picture and they were invited to continue the tiling in the same systematic way that they can see here. And those who were very attentive, careful, obviously did it much better than those who just tried to randomly put shapes in in some order. So this is a good task because they had to observe the pattern. They have to continue it, and of course they are rewarded because the final result is looking very nice. And after a few tries with pentominoes, we moved to isometric grid and tessellations on the isometric grid. And again, they were invited to find some structure here and continue. This is an amazing thing because this is one of the few possible tessellations that pentagons make. And it looks nice. Moving on to slightly older children, we work with the area on a square grid. We started with simple shapes, the rectilinear, so with the shapes that have the borders aligned with the grid lines, and we moved on to triangles and later on to shapes like this one. They're quadrilaterals, but they are concave, so it's not that easy to find its area. They need to be inventive, and there are different ways again for each shape to work with. It's an interesting task again, and those who were particularly interested got tasks that are even more challenging, and they exchanged the shapes that they made themselves, setting the tasks for their friends. We had a few lessons on Venn diagrams as well. This is something that they seem to do a little bit at school, but not enough in my opinion, because they don't have different types of Venn diagrams, usually only one type, the one on the right. And another thing is that they are invited to make up the sets themselves, so they need to think about the relationships between different sets and how they would fit the diagrams. This gives the chance to present different solutions, to compare them again, and to see something that the sets have in common when they have the same type of Venn diagram representing them. And with the oldest ones, we did two large topics in autumn. One was about divisibility tests. We revised the simple tests they know from school, and Makeup invented and proved a few new ones, the ones that's you see an example on the screen. This is a divisibility test for 7, which we discussed its advantages and disadvantages. We proved it using some bits of algebra, and did this with some other divisibility tests as well. So it was a comprehensive set of lessons. We spent half term on divisibility tests. The other half term for the oldest one was about Pigeonhole Principle. This is an important mathematical method of establishing some facts about very uncertain situations. And this is, you can see an example of the question that could be solved using the Pigeonhole Principle. Amazingly, it has lots of applications. Apart from word problems like this one, it could be applied for questions about placing chess pieces on the chessboard, or maybe working with graphs as well. So it's a very important topic in mathematics with a whole range of applications. And finally, I would like to suggest some links for your and your children's entertainment and learning. The first one is very colorful website which offers lots of geometrical tasks and puzzles. Well, you should try it. It's amazing. The second one is the Enrich site, very well known. It's a collection of problems from University of Cambridge for children of different ages. Two further links are for YouTube channels, one from the author of popular math books, Matt Parker, and the second one is from different mathematicians. They discuss mathematical problems and their solutions. Even though it sounds like websites and YouTube channels for adults, it's that it could be well understood by children as well. If not the solution, but then at least the setup of the problem. And I would recommend you to download the GeoGebra software to play with shapes and maybe to learn some basic geometry by observing how the shapes behave. And the last two are apps for geometry puzzles. The first one is about shapes on the square grid, and the second one is about the shapes on isometric grid. You are invited to solve the puzzles, specifically to draw a bisector, or maybe to find the midpoint of a segment using exclusively very limited set of tools. And finally, for the children from, I would say, age 7 to age 14, this is a good set of books. The first, the two on the top are very colorful, present lots of tasks and activities that you can do with your children as well. And the one at the bottom is one of the series of books. They have similar names, math games, brain games, or something like that. It's a very simple paperback, but they have a good variety of puzzles, and it could be really entertaining and helpful to do that. Thank you so much.